When I look at this equation that I'm asked to graph here, I notice it's a rational equation. So I'm going to immediately look for vertical asymptotes. And remember, those happen where you get a 0 in the denominator. We can divide by 0. So I'm going to go ahead and set that denominator equal to 0. And since I've got two numbers multiplied together equals 0, either x minus 2 has to be 0 or x plus 4 is 0. So if x minus 2 is 0, that gives me x equals 2. That's one vertical asymptote. If x plus 4 is 0, then x equals negative 4. So that's my other asymptote, my other vertical asymptote. And then if x goes out to infinity, so if x gets really, really big, then the y value will get closer and closer to 0. So I know I'm going to have a horizontal asymptote at y equals 0 here as well. And my goal really is just to plot a couple of points in each of these sections now. So this graph is broken up into three pieces. To the left of negative 4, between negative 4 and 2, and then to the right of 2. So first, I want to look at between negative 4 and 2. That shouldn't be too hard. If I plug in x equals 0, I get y equals negative 1 over 8. If I plug in x equals 1, I get negative 1 over 5. And 1 over 5 is bigger than 1 over 8. Just like 1/2 is bigger than 1/4. So that's going to help me when I go to graph this. Now to the right of x equals 2, I'll plug in x equals 3 and x equals 4, and I'm going to get fractions there as well. Notice all these y values that I'm getting are fractions, so it's a little inconvenient to work with these y values, but it's okay. What I'm going to do to handle that is scale the y values to be pretty large. So I put 1 pretty high and negative 1 pretty low. And then I'm looking at negative 1/2 and then negative 1/4. And negative 1/8 is about half of negative 1/4. So I plotted the y-intercept and then the point 1 comma negative 1/5. And then the point 3 comma 1/7. And then 4 comma 1/16. And because I know that there will be a horizontal asymptote at y equals 0, I can already tell what the shape of the graph will be to the right of x equals 2. I'm guessing that some of us will feel uncomfortable with this horizontal asymptote and may not be confident that the y values really do approach y equals 0 right there. But if you just think about plugging in some big numbers for x, like x equals 10, x equals 100, x equals 1,000, hopefully you can convince yourself that the y values are getting smaller and smaller. Because, for example, 1 over 10 is bigger than 1 over 100, and that's bigger than 1 over 1,000, that's bigger than 1 over 1,000,000, but they're all bigger than 0. So as x gets bigger, y gets smaller, but it doesn't ever touch 0. That's what gives it the asymptote. All right, and then I went ahead and figured out the y value at x equals negative 3. Gave me y equals negative 1/5. So I could make sure I knew what the behavior looked like from negative 4 to 2. But really, I didn't have to plot that third point because I know that there are no x-intercept on this graph. If you try to set that fraction 1 over x minus 2 times x plus 4 equal to 0, it's never equal to 0. There are no solutions to that equation. So there are no x-intercepts here. So I know the graph can't cross the x-axis. And then I really only need one point over there far to the left. I just need to know, are the y values positive or negative? Because I know what the asymptotes will be doing. And then that allows me to finish the graph.